Welcome to Agentic AI World, your daily interview prep for AI and software engineering roles. I'm your host, and today is episode 14. Today's topic, multi-agent systems and orchestration. If you're interviewing at any serious AI company in 2026, this one is non-negotiable. Let's get into it. So what exactly is a multi-agent system? At its core, it's an architecture where multiple AI agents, each with their own role, memory, and tools, collaborate to solve a problem that would be too complex or too slow for a single agent. Think of it like a well-run software team. You have a planner, a researcher, a coder, a reviewer. Each agent specializes. They pass work between each other. They check each other's outputs. The result is far better than one agent trying to do everything. Interviewers love asking, why not just use one big agent with a massive context window? Here's your answer. First, latency. A single agent doing 10 sequential tasks is slow. Multi-agent lets you parallelize. Second, reliability. Specialized agents make fewer mistakes in their domain. Third, context management. Agents with focused context windows are cheaper and more accurate than one bloated context. Fourth, auditability. You can log, inspect, and debug each agent independently. Now let's talk architecture patterns. There are three main ones you should know cold. Pattern 1, sequential pipeline. Agent A does its job, passes output to Agent B, which passes to Agent C. Simple, predictable, great for workflows with clear stages. Think research, draft, review, publish. Pattern 2, hierarchical. A planner agent or orchestrator breaks down the task and delegates to worker agents. The workers report back. The orchestrator synthesizes. This is what AutoGen, LangGraph, and most production systems use today. The key here is the orchestrator needs to handle partial failures gracefully. What happens if a worker agent times out or returns garbage? Pattern 3, peer-to-peer or collaborative. Agents can request help from each other directly without a central orchestrator. More flexible, but harder to debug. You'll see this in research systems and simulation environments. A common interview question, how do agents communicate? Three mechanisms. Message queues. Agents publish and subscribe to topics. Great for async and decoupled systems. Shared memory or state. A central state object that any agent can read and write. Works well for tightly coupled workflows, but creates contention issues at scale. Direct API calls. One agent literally calls another's function. Simple, but creates tight coupling. The best production systems use a combination. A shared state for workflow progress, message queues for async work, and direct calls for time-sensitive coordination. Let's talk tool use. In a multi-agent system, each agent has its own tool belt. Agent 1 might have web search and summarization. Agent 2 might have code execution and testing. Agent 3 might have database queries and reporting. The important design question here is, how do agents discover and call each other's tools? In LangGraph, agents expose functions. In CrewAI, you define roles and tasks with tool assignments. In custom systems, you'll often build a tool registry, a central service that knows which agent can do what. Now, failure handling. This is where most candidates fall short. What happens when Agent 3 in a 10-agent pipeline fails? You need retry logic with exponential back-off, fallback agents for critical roles, circuit breakers to avoid cascading failures, human-in-the-loop escalation for high-stakes decisions, and checkpointing, saving intermediate state so you can resume, not restart. If you can speak to these in an interview, you immediately signal that you've built real systems, not just toy demos. Let's do a quick design question. Design a multi-agent system that autonomously researches a topic, writes a report, and publishes it to a blog. Walk them through this. Agent 1 is the researcher, takes a query, uses web search tools, returns structured findings. Agent 2 is the writer, takes findings, generates a draft using an LLM, formats to Markdown. Agent 3 is the editor, reviews the draft for quality, factual consistency, and style. May loop back to the writer. Agent 4 is the publisher, takes the approved draft, calls the blog's CMS API, schedules, or posts. An orchestrator manages the flow, handles errors, and logs everything to a persistent state store. Bonus points. Mention that the editor and writer can run in a loop with a max iteration cap. Mention that the researcher can run multiple subsearches in parallel. Mention that you'd add a human approval gate before publishing in a production system. Key frameworks to know: LangGraph for stateful, graph-based agent workflows, CrewAI for role-based agent teams, AutoGen from Microsoft for conversational multi-agent patterns, OpenAI Swarm, lightweight, code-first agent handoffs, and increasingly, Claude's Agent SDK, which supports multi-turn tool used natively. 3 things to remember heading into your interview. 1. Multi-agent is about specialization and parallelism, not just more agents. 2. The orchestrator pattern is the most common in production. Know it deeply. 3. Failure handling is what separates junior from senior. Talk about retries, fallbacks, and checkpointing. That's a wrap for episode 14. If this helped you, subscribe to Agentic AI World for daily interview prep drops. Tomorrow we go deep on another critical topic. See you then.